I have decided to do my presentation over the Transmission Control Protocol, also known as TCP. The Transmission Control Protocol is layer 4 of the OSI model that operates in the transport layer. The purpose of the layer is to transport and provide reliable data delivery services. I believe this is one of the most important protocols that we go over. It is made up of 3 main characteristics for its role as a reliable delivery protocol. TCP operates in the transport layer of the OSI model. The 3 characteristics of TCP are connection-oriented, sequencing and checksums, and flow control. I want to go over the connection-oriented characteristics first. This characteristic makes sure that the connection is established. It uses a process called the three-way handshake to establish the connection. Three-way handshake is a request for connection, response to the request, and connection established. It's where it acknowledges that the connection has been established and it puts it into sequences. After connection is established, data can begin to be transmitted. The second characteristic is sequencing and checksums. This tests the connection. A checksum is a characteristic string that generates a second similar string and checks to see if they match. If they do not match, then the source has to retransmit the data. The purpose of the sequencing characteristic is to keep a sequence number for every transmitted data in case it has to send more than one to connect. This helps it keep organized and in the correct order. Flow control is the last characteristic. It gauges the correct rate of transmission. It can send information faster or slower depending on what speed the receiver needs. This also waits for acknowledgement before sending more data. This is to not overload wherever it is sending to. Also, any picture I have attached, I have put the website where I pulled it from. Next is the fields that are included in a TCP segment. They all represent a series of bits. So if you were to create one long series of bits, it's called a TCP segment. So all of these fields make up the TCP segment and the process it goes through to send information back and forth. The fields that are listed are source port, destination port, sequence number, acknowledgement number, TCP header length, reserved flags, sliding window size, checksum, urgent pointer, options, padding, and data. The data field at the bottom of my list is not a part of the TCP header. It's just where it ends. It talks about it at the end. So the first one I'll go over is the source port. The length is 16 bits. It indicates the port at the source node. This allows a process to be available for incoming or outgoing data. The second being a destination port. The length is also 16 bits. It indicates the port at the destination node. Third is the sequence number. The length is 32 bits. This indicates the data segment's position in the stream of data segments being sent. The fourth one is acknowledgement number, also 32 bits in length. This acknowledgement number is what confirms the receipt of the data by sending a return message to the sender. TCP header length is the next one. The length is 4 bits. This indicates the length of the TCP header in bytes. The header can be a minimum of 20 bytes to a maximum of 60. It's also called the data off-field set because it indicates offset from the beginning of the segment until the start of the data carried by the segment. Next we have is the reserved field. It is 6 bits. This just indicates a field reserved for later use. The next one we have is the flags field. It is 6 bits. This field identifies a collection of 6 one-bit fields or flags that signal special conditions about the other flags in the header. I've made a separate slide to go over these as they are rather long. The next one we have is a sliding window size. The length is 16 bits. This indicates how many bytes the sender can issue to a receiver before an acknowledgement is received. This field also performs the flow control, which we've already talked about is important. And it prevents the receiver's buffer from being deluged with bytes. The next one we have is checksum. We talked about this one a little earlier also. The length is 16 bits. The field allows the receiving node to determine whether the TCP segment became corrupted during transmission. So good to know if any type of segment was corrupted, then this will help us fix it. Urgent pointer, length is 16 bits. This field indicates a location in the data field where urgent data resides. The next field is options. The length can be 0 to 32 bits. The field is what specifies the special options such as maximum segment size a network can handle. The 0 to 32 bits has options. The next field is padding. This length varies, it's a variable length, because it contains filler bits to ensure that the size of the TCP header is a multiple of 32 bits. The next one is data. This length also varies. This field contains the data sent by the source host, and the size of this depends on what is being sent. Back to the flags field. These are the flags available to senders. URG means urgent. This flag contains urgent information for the receiver if it is set to 1. If it is set at 0, this means the receiver ignores the urgent pointer. ACK is acknowledgement. If it's set to 1, it means that the acknowledgement field contains information for the receiver. And if it is set at 0, it means that it will ignore the acknowledgement field. PSH, if it is set to 1, data should be sent to an application without buffering. RST, if set to 1, this means that the sender is requesting that the connection be reset. SYN, if set to 1, the sender is requesting a synchronization of the sequence number between the nodes. FIN, if sent to 1, the segment is the last in the sequence and the connection will be closed. I have attached an example of flags and also how the three-way handshake works. The client sends to the server acknowledges that the client sent what they sent, and then the client sends back an acknowledgement to the server. I believe that this protocol is probably one of the most important ones. It's pretty complex, but I've enjoyed writing this PowerPoint and also doing my PowerPoint over it. And that is all I have. Thank you for your time.